Hello, in this video I'm going to explain magnetic forces. Um, Magnetic forces are kind of hard to understand. They don't really follow your basic logic. A lot of the time you can kind of think of them as like gravity in some cases, but for the most part you really can't. And one way that um, you can follow them pretty easily is something called the right-hand rule. I covered this in a previous video, but I do not know how many of you have actually watched that. So I'd recommend looking it up on YouTube. But the basic idea is that you have your thumb, which you make some axis, usually the z-axis. Then you have your knuckles, or a lot of people like to use their fingers. So then your fingers pointing one way. So this will be thumb. This will be fingers. And then if you look at the fingers as velocity, and this is magnetic field, which I'll explain in a second, both these are vectors. The way your palm is facing is the way that the force is going to be applied, or the way that the direction of the force. You can think of it the pushing, where you're pushing. So if we had this right here, we had the magnetic field going up, the velocity going straight. If it was a positive charged particle, it would push into the page, or push into the screen. So now that you kind of understand what the right-hand rule is, like I said, pause it, go look it up if you need to. A magnetic field is basically similar to an electric field if you've gone over those. And it's what's created when there's charged particles moving. I will go into that more later. I just wanted to go over the magnetic force first because that helps the most, in my opinion. And the magnetic force is usually denoted, well, magnetic field is usually denoted with a B, with this up here is just that it's a vector. And the magnetic force is often then denoted FB. Now, the way that you get that, to get this force, you set it equal to the charge times the velocity. This is a vector too. Cross product, which I'm not going to get into that right now. Cross product, the magnetic field. This is also equal to the absolute value of the charge times the velocity times b times sine theta. Sine theta is the angle between the magnetic field and the velocity. Usually it's 90 degrees, but if you have like a slant, it will not be. If you follow this rule, if it's often 90 degrees, you'll see some of the pictures right down here. And try to take a guess what these are, real quick. This is the velocity. Magnetic field is these lines coming out of the page. And this green arrow is the force, which obviously this blue makes the direction of the particle movement. Now, if you just grab your hand real quick and put it as if the magnetic field lines are coming out and the velocity is going straight across the page, then if you see your palm pointing up, that's the direction of the force. And that is essentially what the magnetic force is. At least for basic physics, that's all you're going to need to know, a lot of you, so I figured I'd just cover this first. Now right here, there's two different types of arrows. This one, the circle with an X, and this one, circle with the dot. Circle with the dot pictured as an arrow point coming out of the page. This right here means that the magnetic field is that something is coming out of the page. So coming out. like I said, picture it like an arrow point. The X is like something going into the page. And picture it like the back of an arrow. I forgot what it's called offhand. You know what I mean, the little feathers in the end. If you want to think of it some way else, you can, feel free. Okay, so since these are coming out of the page right here, and we have a velocity coming in like this, if you, again, put your hand perpendicular to the page, magnetic field lines coming out, make those your thumb, and they're coming out of the page. Make your fingers the velocity. This is the velocity right here. You'll then get a force going up, and the particle will go like this. It'll arc up. If we come in from a different direction, say, I'll go a different way. Say from the bottom, again, put your fingers perpendicular page, thumb coming out for the magnetic field, fingers for velocity, and you actually get a force that is pushing to your left. You then get this. I know this seems weird that the force isn't applied in the same direction every time, but it's the way I think of a magnetic field is when electrons are moving or charged particles are moving, they create a little gap. Like if you picture throwing a ball or a bunch of balls in a row really fast, there'll be a gap in between those balls. Now the gap in between those balls leave a lack of gravitational field in between them. And that is essentially what these electrons are doing. There's a magnetic field going, an electric field going, and it's leaving gaps of potential energy, which creates magnetic fields, which is what those charged particles are trying to fill. So there's a force being applied to fill those gaps. I hope that gives some explanation. Just remember, FB is equal to QVB sine theta. And the theta is, this right here, is the angle between V and B. So find the angle between those two and you'll get that theta. You can also use a cross product, though I get the feeling a lot of you looking at this video, you not know what the cross product is. That's okay. Essentially, it just turns into this. Unless you're talking about vectors. But whatever, most classes don't deal with that. So I'll make more videos to explain this. Hope this gives some explanation, and feel free to visit my website and suggest a different way I can explain it to help you out. Thank you.